In this lesson, we are going to kind of work backwards. Rather than having a radian and just saying sine of pi over 2 and we get an answer instead, we're going to try to figure out what angle would have given us this answer. And there's a good chance that it's going to be more than one answer to these. So we're finding an exact radian measure or measures given a particular interval. Most of the intervals that we're going to look at the same interval on all of these, is we're going to go from 0 to 2 pi. All right, so basically one cycle around the unit circle. And this is my version of a unit circle, that my answers are going to come from either 30, 60, 90 triangles, 45, 45, 90. This tells me where my what my signs are in each of my quadrants. And then if I can't connect it to a triangle, then it's because I'm landing on an axis. And this takes care of that. Okay, so sine of some angle is going to equal negative root 3 over 2. So a couple things we can do is we could either figure out what reference angle that works for. So root 3 and 2 is we are looking for sine of some angle is going to be a root 3 over 2, and then we'll talk about the fact that it's negative. So root 3 over 2 is sine. So if I do sine of 30, I get a 1 over 2. If I do sine of 60, I get a root 3 over 2. So we are looking at a 60-degree reference angle. So reference angle equals 60. All right, now it goes to our quadrant. So sine is negative in these two quadrants. Everything's positive in this quadrant, sine's positive in this quadrant, tangent's positive in this quadrant, cosine's positive in this quadrant. So a smart trade class. So sine's going to be negative in these two with 60-degree reference angles. So if I give myself a visual to that, I'm looking at this and I'm looking at this with 60-degree reference angles. So if this is 60, what does it take then to get here? So if that's 180, then I'm going to add 60 to it. I'm looking at 240. But notice your interval is 0 to 2 pi, so we want it in radians. So if we're talking about a bunch of 60s, that means we are talking about a bunch of pi over 3s. And how many 60s does it take to get to 240? That's going to be 4. So one of our answers is 4 pi. And then we're 60 shy of 360 here, which makes 300. And it's going to take 5 60s to get to 300. So 5 pi over 3. And those are our two answers. So if we were to do sine of 4 pi over 3 or sine of 5 pi over 3, we would be getting a negative root 3 over 2. All right, so same idea with tangent. This one is a problem that was rationalized. So if you've done enough of these, this came from actually a 1 over root 3 prior to rationalizing. So it would have started here and then it kind of went back to here. So a 1 over root 3, again, goes back to our 30, 60, 90 triangle. So tangent of 30 is going to get us a 1 over root 3. So we're looking at a reference angle of 30. And then I like to draw myself a visual for it. Tangent is going to be negative in these two quadrants. So I'm going to draw a 30-degree reference angle in that quadrant and a 30-degree reference angle in that quadrant. So this is going to be 30 degrees shy of 180. This is going to be 30 degrees shy of 360. So we're looking at 330 and 150 are our answers, but in radians. Reference angle of 30 is anything over 6. And it takes us 5 30s to get to 150. So 5 pi over 6. And then it takes us 11 30s to get to 330. So 11 pi over 6. All right, so let me do two others. So let's say you have secant theta is just root 2. All right, well, triangle that has a root 2 is going to be our 45, 45, 90. So secant of what angle, which really, if I'm really going to work this problem, I'm really going to think of this as its reciprocal. So secant goes with cosine, and if we make this a fraction, we make it over 1. And so we're really looking for a 1 over root 2. So cosine of 45 is going to be a 1 over root 2. So reference angle is 45. Quadrant-wise, we're looking for where cosine is positive, which is going to be in these two quadrants. So I'm going to draw 45 and a 45 in those two quadrants. So first one's 45, and then here we're 45 shy of 360, so that is going to be 315. And so our actual angles are going to be pi over 4. Anything over 4 is a bunch of 45s. So that's 145, 2 45s, 3, 4, 5, 6, 7. 7 pi over 4. All right, and then the last one is, what if we had to do sine of theta equals -1? All right, so if I look at my stuff, -1, -1 is not going to match any of these triangles, and so I kind of have to shift gears a little bit. I'm not going to be able to connect it to an angle on a triangle. Instead, I'm actually going to be talking about the unit circle and just kind of one of the axis points. So it goes now to the fact that sine of theta refers to a y value. So I'm really just looking for where a y value is going to equal a -1, which is going to be right here. So that is 270 degrees. So 270 degrees, which again, we want the radian version of that. So our answer is going to be 3 pi over 2, because over 2 is a bunch of 90s, and we need 3 of them. Okay, so that was a few examples of kind of working backwards a little bit, where they give you the value, the output, and you got to figure out what angle / input or radian measurement it took to get that answer. Thanks.